Here's the problem. The limit of this function, sine of 2x minus 8 divided by square root of x minus 2 as x approaches 4. Okay, so knowing from your limit of functions, to evaluate the limit of functions, let's just plug in this value of x into this function. So we're going to have sine of 2 times x, that is 2 times, where x is 4, where x approaches 4. We're going to have 2 times 4 minus 8, okay, divided by the square root of, where x approaches 4, 4 minus 2. Okay, so sine of, this will become, sine of 2 times 4 is 8. Okay, so 8 minus 8 divided by square root of 4 is 2 minus 2. So 8 minus 8 is 0. And sine 0 is 0. 2 minus 2 is 0. Wow! 0 over 0. What's the value of 0 over 0? Indeterminate. So we don't want this. So we're going to be applying L'Hopital's rule to go about this. So L'Hopital's rule will let us to differentiate the numerator and denominator of the function, then plug in the values again and evaluate. If the result is still indeterminate, 0 over 0, we will continue with the differentiation. Okay? Otherwise, we stop. So applying L'Hopital's rule here, we're going to differentiate the numerator and the denominator. So the derivative of the numerator with respect to x would become the derivative of this function, the numerator, sine of 2x minus 8, okay, divided by the derivative of the denominator. That will just become derivative of the denominator with respect to x. That's going to give us the square root of x minus 2. Right. So let's go on with the derivative. So differentiating this numerator, you know this numerator is a function of a function. We're going to differentiate sine of this function. That will give us cosine of that function, 2x minus 8. And we go into the inner function, 2x minus 8. We differentiate 2x. The derivative of 2x is just 2. And the derivative of negative x is negative 8 is 0. You know that's a constant. Alright, so divided by, differentiate the denominator. The derivative of the square root of x is what? Is 1 divided by 2 root x. And the derivative of negative 2 is 0. Alright. Okay, so we go on to find the limit after differentiating to test as x approaches 4. Okay, so what will be the limit of this function as x approaches 4? So let's start evaluating that by plugging in 4 for x. Okay, that will become, this will become cosine of 2 times value of x there is 4 minus 8 times 2 divided by 1 over 2 root 4. Okay, so this implies cosine of, now 2 times 4 is 8 minus 8 is 0 divided by, now the inverse of this man, okay, simply bring it up. And we have that cosine of 0 is what? Is 1 times 2. The square root of 4 is 2. 2 times 2 is 4. So this becomes 1 times 2 is 2. 2 times 4 is 8. Right. So 8 is the limit of this function.